Now that we have a facsimile of the casting body and the true 3D shape that is the finished pump housing, we can combine them together in the setup. I've already done that. If you look at the geometry view, you'll see that in the workpiece I've already specified the part geometry and the blank geometry. I've also already created some tools. First, I have a face mill that I retrieved from the library, an end mill that I also retrieved from the library. I'll use this to go around the perimeter of the circular face. A T-slot cutter that I can use to undercut the face on the other side. A center drill and a drill. Let's get started. I'll switch back to the program order view. I have already identified my operation as face 1. Create operation. Choose the floors and walls module. Program group is face 1. Using the face milling tool, workpiece geometry, and mill finish. First, select the face that is to be machined. Cut area floor. Next, specify some other parameters like the cut pattern. Follow periphery. The face mill only has 8 millimeters of flute length, and there's 10 millimeters of stock, so I'll set my depth per cut to 5 millimeters. Next, cutting parameters. Under strategy, I want my pattern to go inward, not outward. For connections, instead of cutting across the void in the center, I'll simply follow the existing cut pattern. Under corners, I'll set path smoothing for all passes and leave the default parameters. Finally, under containment, I'll set the blank geometry as the blank, and I'll specify the tool overhang at 75%. Choose OK. Now I can generate the operation. Let's check our work. So far, so good. Now that the top of the face has been machined, we need to mill the outside perimeter. Create operation. This time I'll use the end mill. Geometry will still be workpiece, method will still be mill finish, but this time I'll use a different operation type. I'll use planar profile to mill the OD of the face. Choose OK. Planar profile works off of boundaries that come off the edges of the solid itself. So first I'll specify a part boundary. Choose the boundary of the part that I wish to machine. Set the method to face, material on the inside. I'll turn ignore holes on, and then I'll choose the top face of the pump. My boundary is created. Now I need to specify a floor. I want the floor to be a little bit past the bottom of the stock so that I make sure that I clean it up completely, because castings have varying thicknesses. So what I'll do is I'll choose OK for now. Then I'll go into my geometry toolbar and create a datum plane that I will then use as the floor. Choose that face, and I'll specify my depth underneath that as 5 millimeters. That should ensure that I get adequate machining beyond the casting edge. Edit the plane of profile operation. Now for the floor plane, I can choose that datum plane that I created. Next, specify some parameters. Under non-cutting, I want to make sure that the operation has plenty of clearance to come in from the side. So I'll set the minimum clearance as 30 millimeters. Now let's generate the operation. Looks good. I'm ready for the next operation. To machine the back side of the top face, I'll use another planar profile operation and a T-slot cutter. Copy the existing operation, paste it inside, and rename it. Now edit the operation. First, replace the tool with the T-slot cutter. Then replace the part boundary. I'll use curves and edges and pick the edge that marks the inside of the radius on the part itself. If I choose, I can add some custom member data to make it drive past that geometry radius just a little bit. I'll say minus 5 millimeters for that. Next, I'll choose the floor plane. This is a little bit tricky because the floor plane has to be the bottom face of the pump housing body plus the thickness of the T-slot cutter. CAM Express will make an inner part copy of this face. The T-slot cutter is 10 millimeters thick, so that's what my floor plane offset needs to be. Finally, I'll modify the non-cutting moves so that this large T-slot cutter avoids the area as it's moving underneath the face. Minimum clearance of 150 millimeters and an engage radius also of 150 millimeters. Generate the operation. and the underside of the face is cut. Now let's center drill and drill the holes in the top face. First, I'll hide the display of the blank geometry since I no longer need to see it. Next, create a geometry group that consists of the holes. Hole making, manual hole inside the workpiece. Select the holes. Then create a manual drilling operation to machine those holes. Manual hole making, using my center drill and drill method. I can accept the default parameters here. We're going to be drilling to a depth of 10 millimeters. Once again, I can use the copy-paste functionality to make a drilling operation. I'll change the depth to 75 millimeters, and I'll change the tool to the drill tool. Generate the operation, and it looks like I'm finished with the top face. Thanks for watching.